Okay, welcome back after the break. Let us continue with this exercise 13.1 and now we are taking 7th question. So the question says, Shanti's sweet stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger box of dimensions 25 centimeters by 20 centimeters by 5 centimeters and smaller box of dimension 15 centimeter by 12 centimeter by 5 centimeter. For all the overlaps, 5% of extra total surface area is required. If the cost of cardboard is rupees 4 for 1000 centimeters square, find the cost of cardboard required for supplying 250 boxes of each kind. The first thing that we have to understand here, we are talking about boxes. Okay, we have to make the boxes from cardboard. Okay, and when we see box, that means it is going to be a cuboid. All right. Now here it is not mentioned whether it is going to be open or closed box. We'll assume a closed box because we can see there's always a cover on the sweet box. So we will consider the entire surface area. So let us first write down the dimensions because there are two types of boxes here. One is the bigger and other one is the smaller. So we'll have two different dimensions. So first we will say for the bigger box, L is equal to 25 centimeter. B equal to 20 centimeter and H is 5 centimeter. So that is the first thing that we have to note down. L is 25 centimeter, length is 25 centimeter, then B is 20, the breadth is 20, and H is equal to 5 centimeter, the height is 5 centimeter. This is for the first box. For the another box, which is the smaller one, so we'll note it for the smaller one also. For smaller one, the length is 15, the breadth is 12, and the height is 5 centimeters. Okay, so there are two different types of boxes and they will have different dimensions. So for the smaller box, L is 15 centimeter, B is 12 centimeter, and H is 5 centimeter. Now here we have to find the surface area. Along with the surface area, for all the overlaps, 5% of total surface area is required, which is extra. All right, and we have to find the cost of cardboard, total cost of cardboard, that is the cost of cardboard given here, the rate is 4 rupees for 1000 centimeter square, and we have to find the cost of cardboard required for supplying 250 boxes of each kind. So first of all, let's go step by step. First, we'll calculate the surface area for one box. Okay, and here it is clearly mentioned that it is going to be the total surface area because यहाँ पर लिखा है 5% of the total surface area is required extra. The first thing we find the total surface area and then we'll find the 5% extra. Okay, because we need some extra material for overlapping. The first thing that we'll do here is we'll take one box at a time. Let us say total surface area. Now for the total surface, for the bigger box, we'll find the total surface area. So just write down this and calculate it along with me. Total surface area of the bigger box. We use the formula for the total surface area of cuboid, that is 2LB plus BH plus LH. So we'll use this one, 2 in the bracket, length into breadth plus breadth into height plus height into length. And we will use the values, the dimensions which are given for the bigger box. So we have 2 in the bracket, length into breadth, that is 25 into 20 plus breadth into height means 20 into 5 plus length into height, which is 5 into 25. Okay, I'm giving you a minute just to calculate the total surface area. Do this working, all of you, and tell me what is the final answer you are getting for total surface area. Okay, you has given me the answer already. Let's see who else is giving me the answers. Kaustubh has given me the answer. Okay, I have only asked you the total surface area of the bigger box. I am not asking you the final answer as yet. Okay, Sayyam has given the answer. Janvi has given the answer. The first thing we do is multiplication in the bracket here. So it will be 2 in the bracket, 500 plus 100 plus 125. And then will be the addition. So 500 plus 100 is 600 plus 125 is 725. So it will be 2 multiplied by 725. Okay, so 2 multiplied by 725, the double of 725 will be 1450. So 1450 centimeter square. Remember, the dimensions are given in centimeter. So we have to use the unit as centimeter square. This is for the bigger box. Okay. There is one bigger box. Similarly, there is a smaller box also. So on the same lines, we'll find out the surface area of smaller box also. So do this one now. Total surface area of the smaller box. The same formula we use. 2 in the bracket LB plus BH plus HL. But this time, the dimensions are different. So here it will be 2 in the bracket, length into breadth means 12 into 15 plus breadth into height means 12 into 5 plus L into H, that is 5 into 20. Okay. Same way calculate this also. Calculate this everyone. Okay. I already started getting the answers. The only thing you have to be little careful about is 15 into 12. उसको थोड़ा ध्यान से करना पड़ेगा. Otherwise 12 5 and 5 15. These two numbers are easy. Okay. So I think you need to check your calculation again. Kaustubh, Aradhya, Neev, these people have given me the answer. Mukta has also given me the answer. Okay, so here 12 into 15 will be 180. 12 into 5 is 60 and 5 into 15 is 75. So 2 in the bracket 180 plus 60 plus 75. So it will be 2 multiplied by 315. So 315 का double करना है हमें. So 315, the double will be 630. So that's the surface area of the smaller box. So we know surface area of each box. Okay. So it is centimeter square, 630 centimeter square. So now we know the surface area of each box. Now how many such boxes are required? Now understand students, we require 250 such boxes. So what we can do is we can multiply this answer 1450 by 250. Okay, so we'll get the surface area of the all bigger boxes. Then we'll multiply this second answer again by 250. Okay, so we'll get the surface area of all the smaller boxes and then we'll add them. In दोनों को हम add कर देंगे. So we'll get the total surface area of the cardboard required. But instead of doing that multiplication again and again, what we'll do is, we know that both the boxes are 250. Okay, so what we'll do is we'll take the surface area of one bigger box. Okay, and we'll take the surface area of one smaller box. Okay, area of one bigger box and surface area of one smaller box, and we'll add them first. Okay, so we'll get area of each box. Okay, total surface area of each box total. Okay, and then we'll multiply that addition with 250. So it will save our calculation. So let us do the addition of both the surfaces. So we have total surface area of one box of each type. See, the word each type is important. Okay, just write down this sentence. Total surface area of one box of each type. Okay, the total surface area of one box of each type should be the addition of total surface area of each box. So it is, for the bigger it is 1450 and for the smaller it is 630. So 1450 plus 630, just add them. Okay, so it will be 2080. So this is the surface area, total surface area of one box of each type. दोनों का मिला के एक स्मॉलर और एक बिगर का मिला के होता है 280. Now this 280 is for one box of each type and we require 250 such boxes. Remember, okay, we have to supply 250 such boxes. तो अभी हमें क्या करना है? अभी हमें एडिशन को ही 250 से मल्टीप्लाई करना है. Okay, so let us do that multiplication. So that will be the cardboard required for making 250 boxes of each type. So we will say total surface area of 250 boxes of each type. So we are including both of them, bigger as well as smaller. So just note this. You can just use the short form TSA of 250 boxes each type, but use the word each type, that is very important. Total surface area of 250 boxes of each type will be equal to 250 multiplied by 2080. Just do this, all of you. 250 multiplied by 2080. Just get the calculation. All right. Neve, Mukta, Ayush, your answers are correct. Ayush, आपने शायद एक digit miss कर दिया है. Check कर लो एक बार. Okay, Sayyam has told me the cost also. But same, there is one more step in between. Huh? So when we multiply these two, 250 into 2080, the multiplication will be 5,20,000 centimeter square. So this is the total cardboard required. इतना cardboard की हमें जरूरत होगी to make the boxes. All right. So this is the cardboard required to make the boxes ideally. मतलब cardboard में इतना boxes में इतना cardboard use होगा. But remember, when we make anything out of cardboard or anything for that matter, it is not guarantee that we will, if we buy 5,20,000 centimeter of cardboard, we will not be able to make these 250 boxes, because we will need something extra for overlapping, for folding, for cutting. Okay, there's always a little bit of wastage, isn't it? So if you want to make cardboard boxes whose area is 5,20,000, you cannot just take the raw cardboard of 5,20,000. You need something extra, थोड़ा सा extra लेके रखना चाहिए, so that cutting में and overlapping में वो use waste भी तो होता है. Okay, so we need 5% extra. All right, so it is mentioned in the question, we want 5% extra. Now we know that it is 5,20,000 the cardboard required, and we need 5% extra also. So the total cardboard we should order is 5,20,000 plus the 5% extra. Okay, 5,20,000 तो आएगा ही, उसमें 5% extra भी आएगा, and 5% of again 5,20,000. So it will be this way. Cardboard required, including 5% extra, will be equal to 5,20,000, the actual cardboard which will be used, plus the additional of 5% of total surface area. Adding 5% of 5,20,000. Just add the statement, everyone. So 5,20,000 plus 5% of 5,20,000. So the first number will remain the same, 5,20,000. Now 5% of 5,20,000 should be 5 upon 100 multiplied by 5,20,000. Just calculate the second part, second term, this one. इसको calculate कर लो. Okay, so the first part or the first term will be 5,20,000 as it is. In the second term, you can first cancel the zeros. Okay, I'll just show you the calculation also. So we can cancel the 2 zeros and then multiply 5 into 5,200. So 5 into 5,200 will be 26,000. Okay, so the total cardboard required will be 5,20,000 plus 26,000. Okay, so 5,20,000, we have to add another 26,000 to it. So when we add it, the cardboard we require, okay, is 5,46,000 centimeters square. Okay, this is the required cardboard. This much cardboard we should purchase or we should buy to in order to make 250 boxes, including the 5% of additional overlapping or wastage cardboard. Okay, so हमें ये तो पता चला गया 5,46,000 is the cardboard required. Fine. Okay, so next thing is the cost. We know that we have to bear some cost for this. अब यहाँ पर आप cost question में पढ़ोगे तो just see that line in the question. It says total cost of the cardboard is rupees 40. The total cost of cardboard is rupees 4 for 1,000 centimeters square. If you remember one question we did where we had the cost of 1 meter square. Okay, it was for a unit area, but here it is for 1,000 centimeters square. It is not for 1 unit 1 centimeter square. तो यहाँ पर जो rate दिया है ना, the rate is not given for 1 centimeter square. So you cannot directly multiply this 4 into the surface area. It is given for 1000 centimeter square. So if it is 4 rupees for 1000 centimeter square, we should convert it. How much is the rate for 1 centimeter square? So for 1000 it is 4. So for 1 centimeter square, it should be 4 divided by 1000. Just see the first two lines now on the screen in the solution part. The first thing is, just note down this: cost of 1000 centimeters square of cardboard is 4. Okay, cost of 1000 square centimeter of cardboard is 4, but we want it for 1 centimeter. So what we should do is, we should divide this 4 by 1000, because देखो यहाँ पर जो 1000 था ना, 1000 का क्या हुआ है, 1 हुआ है ना. So we have divided this by 1000. So on the right side also we have to divide by 1000. So it will be 4 upon 1000 rupees. We'll just keep this fraction as it is. Decimal में convert करने की कोई जरूरत अभी तो नहीं है. So we have cost of 1 centimeter square of cardboard is rupees 4 upon 1000, and this is the cost which we can directly multiply into the total surface area. Okay, so this is the rate. When we say cost of 1 centimeter square, it is actually the rate. So now we'll get the final cost. So just do this working. Cost of cardboard, or we can say the total cost of cardboard here. Total cost of cardboard will be total cardboard required multiplied by the rate, or we can say the cost of 1 centimeter square. All right. So just do this. Total cardboard required multiplied by cost of 1 centimeter square of cardboard. Okay, so the total cost of cardboard will be equal to the total area, that is 5,46,000, multiplied by the cost of 1 centimeter square of cardboard, that will be 4 upon 1000. So this looks easy now, as we can cancel the zeros directly. Okay, we can simply cancel the 3 zeros, and you only have to multiply the number 546 by 4. Just do this, all of you. Just do this multiplication, 546 into 4. Okay, get this multiplication. Yes, Janvi has given me the answer. Mukta, Neve, Kaustubh has given me the final answer. Mukta, I think, yeah, you gave me 2 answers. The initial was, I think, wrong, then you changed it. Okay. Ketki Siddhi has given the answers. All right, so when we multiply 4 into 546, we get the answer as 2,184. So that's our final cost. So write on this as the final answer. Total cost of cardboard is rupees 2,184. In our 13.1 exercise, we have done questions on surface area of cuboid and cube also, but we haven't done cube yet. So in the initial exercises, that is 13.1, we have questions based on surface area, and the later exercises 13.5 onwards, we have the question based on volume. But because we have already studied this object cuboid, so we are going to take the question based on volume also. So we are taking the question from 13.5. Let's solve this. We have this 13.5 question number 4 that says, find the cost of digging a cuboidal pit 8 meter long, 6 meter broad and 3 meter deep at the rate of 30 per meter cube. Now again, here the question is based on cost, but unlike previous question, it is not based on the surface area. Here it is said, we need to find the cost of digging the cuboidal pit. So what do you understand from this? To dig a cuboidal pit, which is 8 meter long, 6 meter broad and 3 meter deep. So we can see the length, breadth and height. So it indicates that the pit is a cuboid, okay, and the rate is also given 30 per meter cube. So what should we calculate in this case? Okay, yes, correctly said by Kaustubh here. We will find the volume. Why volume? Because we are digging out the cuboid. The cuboid pit we are digging, so we are removing something from it. Okay, so we are dealing with the space occupied by the cuboid or the capacity of the cuboidal pit. That means we are dealing with volume. One more hint here is the rate is given 30 per meter cube. That meter cube is the unit of volume. So it is very easy. We have to understand, find the volume here. So let's find the volume here, all of you. So just note down the information. We have length, breadth, and height. All three are given. Here the word depth is used, deep. Okay, it is same as height in case of a pit. So just write down. For the cuboidal pit, L is equal to 8, B is equal to 6, and H is equal to 3. So I think you have understood this. So yeah, we have already started giving me the answer. Okay. So the first thing we should do is we should calculate the volume, and the volume formula is very easy if you remember. So just use the formula for volume. Cost of digging the cuboidal pit, as we have discussed, it is rate of digging multiplied by the volume. So we know the rate already, it is 30. The thing we have to calculate is volume. So let's first calculate the volume with the help of the volume of cuboid, that is length into breadth into height. So you will calculate the volume first. Do this, all of you. Volume is length into breadth into height, and the numbers are very easy. So just do it. Volume equal to, and I want answers from everyone. Only few of you have given me the answer. Okay, so the volume of the pit is length into breadth into height. That means 8 into 6 into 3. Do it quickly. 8 6 are 48. 48 into 3. So 48 into 3. This will become 144 meter cube. Take care of the units. It is volume. So the volume is equal to 144 meter cube. Okay. We have to dug out this cuboidal pit whose volume is 144. The rate is going to be 34 meter cube. So we have to multiply this by 30. So cost will be, write on this sentence, cost of digging the cuboidal pit is equal to rate multiplied by volume of pit. Cost of digging the cuboidal pit is equal to rate multiplied by volume of the cuboidal pit. So it will be 30 multiplied by 144. So the cost is 4,320. Yes, as most of you given, but yes, there's a mistake few of you have made. This is a cost. Okay, this is a cost for per meter cube. So the unit should not be meter cube. The unit has to be in rupees. Okay, so make sure you don't write the unit meter cube there. The final statement should be cost of digging the cuboidal pit is rupees 4,320. The next question that we have is exercise 13.5, question number 9. The question is, a river 3 meter deep, 40 meter wide is flowing at the rate of 2 kilometers per hour. How much water will fall into sea in a minute? Now this question is completely different from all the other questions. In previous questions, either we had a box or a cuboidal pit. It was clearly mentioned as a cuboid. Now here we are talking about a river. Now obviously river cannot be a cuboid, but then we can relate it to a cuboid. Let's see how. Okay, so first we know the depth of the river. The depth is 3 meter, okay, and it is 40 meter wide. Now the river is flowing at the rate of 2 kilometers per hour. This is the most important information. What does that mean? Okay, that means the length of length covered by water in an hour is 2 kilometers. Okay, that will act as the length of the cuboid. Okay, so first let's just note down these dimensions, and then we'll think what to calculate here. This means the rate here, the rate of flowing here means the water in river flows 2 kilometers in 1 hour. Okay, so L is 2 kilometers. So we have to understand here, since the water flows at the rate of 2 kilometers per hour, the volume from volume from 2 kilometers of river flows into the sea in 1 hour. Okay, so see, let's understand what this means. अभी सबसे पहले तो एक चीज याद रखो, just imagine a river. Now river will be anything like this, कुछ ऐसा होगा. Okay, anything like this. We don't know what exactly the shape of the river. It is flowing like this. Okay, but at a particular point, let's say at a particular point, जहाँ पे ये sea में जाके enter हो रहा है, at that particular point, let us say it opens up like this. Let's say the river flows through this thing. Okay, ये समझो river का opening है, and through this the water is falling into sea. Just imagine like this. now अब ये जो opening है ना, इस opening का we know that it is 3 meter deep. तो इसकी जो height है ना वो 3 meter deep हो जाएगा. Okay, the width of the river is 40 meter, so it is 40 meter wide. Okay, अभी जो opening है river का ये 40 meter है. अब यहाँ पर how does this 2 kilometer help? The 2 kilometer indicates that if we let the water flow for 1 hour, it will reach the length of 2 kilometer. तो जो water जो fall हो रहा है ना, यहाँ पर जो water fall हो रहा है ना, if you imagine a straight line, okay, if you imagine a straight line, so in that straight line, it will look like a cuboid. Okay, if you allow it to flow, if you allow the water to flow for 2 hours, let's say from this point, you allow it to flow for 2 hours like this. Okay, imagining a straight line like this. So, sorry, 1 hour it is. If you allow it to flow for 1 hour, ये जो length cover करेगा ना यहाँ पर, ये जो length होगा, this length will be 2 kilometer. Okay, okay, the height and the width we will assume same. So now here, see, if we imagine it like a cuboid, okay, this looks like a cuboid here. Okay, this looks like a cuboid. So the volume of water which is falling into the sea, actually this is not, the river is not going to take this shape. The water will keep on falling, but the volume of water falling into the sea will be equal to the volume of a cuboid whose length is 2 kilometer in 1 hour, and the height is 3 meter and the width is 40 meter. Okay, so we have to find the volume of this cuboid. Now this is the volume of cuboid which is equal to the volume of water falling into the sea in 1 hour. Okay, so first just note down this. Since the water flows at the rate of 2 kilometer per hour, the volume of water from 2 kilometer of river flows into the sea in 1 hour. Okay, the volume of water from 2 kilometer of river flows into the sea in 1 hour. All right, so here we'll take L is equal to 2 kilometer. That kilometer can be converted into meter because the other dimensions are in meter. So just take 2000 meters. Then we have the depth and the width. So the width, that means the breadth, B is equal to 40 meter. Then the depth, that is H, is equal to 3 meter. All right. So now we know all the 3 dimensions. For 1 hour, the length is 2000 meter, the breadth is 40 meter, and the height is 3 meter. So now it is very easy to calculate volume because we are imagining it like a cuboid. So just write down volume of water flowing into the sea in 1 hour. Volume of water flowing into the sea in 1 hour is equal to volume of the cuboid. Okay, it is same as the volume of the cuboid. To write down volume of the cuboid, use the formula of volume, that is length into breadth into height. Do this calculation, everyone. Do this calculation and tell me the answer. Just I have got the answers from many of you. Let's see the answers here. Okay, let's see the calculation first. So it is going to be length into breadth into height, that is 2000 into 40 into 3. So it is easy now. 2000 into 4 will be 8000, 80,000 into 3, that is 2,40,000 it will be. But then see, this volume is going to be the volume of water in 1 hour. Remember, it is going to be in 1 hour. This is how we can calculate because it was given 2 kilometer in 1 hour. So this is the volume. If you multiply this, you get 2,40,000. We haven't multiplied it yet. Even if you do it, not a problem. Okay. So here it is. If you multiply, it will be 2,40,000 in 1 hour. But are we interested in 1 hour? The question highlights the volume of water fall into the sea in 1 minute. So we are not interested in the volume of water falling in 1 hour. We are interested in minute. Okay. So we know that 1 hour has 60 minutes. So to convert it into minutes, we have to divide this value by 60. So write down the next statement. Volume of water flowing into the sea in 1 minute. Okay. So the volume of water flowing into the sea in 1 minute is the volume of water flowing in 1 hour, that is 2000 into 40 into 3 divided by 60. Okay, or you can write 2,40,000 divided by 60. Okay, the unit will again still be meter cube. So we can do cancellation here. Even if you write 2,40,000, you can still divide it by 60. So you can cancel the zeros, then we can divide 3 to the 60, or we can say 320 the 60, and 0 zeros gets cancelled. Then we have 2 to the 4, or we can say 20 to the 40. So we have 2000 multiplied by 2, that will be 4000 meter cube. Okay, so this is going to be our final answer. The volume of water flowing into the sea in 1 minute is 4000 meter cube. Okay, this was a little tricky one because here the shape wasn't mentioned as a cuboid, but you have to just imagine, you know, a river, the opening of the river into the sea has the depth of 3 meter and width of 40 meter, and the length of water covered in 1 hour will be taken as 2 kilometers. Okay. So today, in today's session, we have seen the questions based on cuboid. Okay. So this was the last question of this session. You don't have to rejoin now. So in the next session, we'll see the next object, that is the cube. A cube is a special type of cuboid. All the properties are almost the same for a cube and cuboid. We'll see that in the next session, and we'll solve questions based on cube as well as cuboid. And there are few questions in which we have to take cube and cuboid both. So all such questions we'll solve in the next session. I hope all the formulas and the questions taught in this lecture are clear to you. Okay, so thank you everyone.